Hey Condors, it's your boy Mr. Roberts coming at you with a little social distancing science. Hey, before we get started, don't forget, hit that subscribe button, and once you subscribe, mash that bell so that you don't miss any episodes of social distancing science. Let's look at our agenda and see what we're doing today. We've got four things. We're going to read about how does the moon move. We've got a lab, moon phases. We're going to read about why does the moon appear to change shape, and we've got a lesson review on our lunar phases. Without any further ado, let's get started. Log into McGraw Hill with the waffle and follow along. We're starting off with read about how does the moon move. So, one rotation, one revolution. The moon also rotates as it revolves around the Earth. One complete rotation of the moon takes 27.3 days. This means the moon makes one rotation in the same amount of time that it makes one revolution around the Earth. Because the moon makes one rotation for each revolution of the Earth, the same side of the moon always faces the Earth. The side of the moon is called the near side. The side of the moon that cannot be seen from the Earth is called the far side of the moon. Some people also call it the dark side of the moon, which is a little bit of a lie because it's not actually dark all the time. So we're going to look at some moon phases. What are the phases of the moon? So the sun is always shining on half of the moon, just like the sun is always shining on half of the earth. However, as the moon moves around the earth, usually only one portion of the moon's near side is lit. The portion of the moon or planet reflecting light as seen from earth is called a phase. How many phases are there? Let's find out. Okay, we're actually going to do this virtually. So I'm going to show you, and you're going to record. And you're going to, so you should be on this data and observation here, and you're going to be writing a description of what we see as we move the moon around. In order to do this, let's go to the classroom and check out something I've got up on the display. Hey, look, it's a representation of the moon. If you look, you'll see we've got the um, so the sun would be way up there on the left side of the screen, um, and the moon is going around the Earth. We are starting here at the phase that's called the new moon. Now, so in the aha in that upper little box, that shows you what you would see from the Earth if you were looking at the moon at that point. So let's go through one orbit of the moon. Okay, so we start with that sliver, and then we're to the half moon. So the moon is waxing, and then it starts to wane. It starts to get smaller until it disappears. What are these different moon phases called? Well, our first phase is the, hold on, new moon. Our second phase is the waxing crescent. Then we have our first quarter, the waxing gibbous, the full moon, the waning gibbous, the third quarter, and the waning crescent. Okay, back to the curriculum. So you typed in your phases and your descriptions here. If you need to review the video, feel free to do that. And let's go to the next. Now it's got some questions I want you to answer. So, how does the position of the sun, the moon, and the earth produce the different phases of the earth? Answer here in just a short sentence. And why is half of the moon always lit? Why do you usually only see part of the moon's lit half? And the last question is, why is the moon not visible from Earth during the new moon phase? Pause the video, answer these, and then we'll continue on. Let's see, what do we have next? Looks like next we're going to be reading about why does the moon appear to change shape. So, while the moon rotates and revolves around Earth in 27.3 days, the length of the lunar phases cycle is 29.5 days. The moon's appearance changes as Earth and the moon move. Depending on where the moon is in relation to Earth and the sun, observers on Earth see only part of the light the moon reflects from the sun. So, during the waxing phases is when we see more of the moon's lit side each night. So, during the first week is the first quarter. As the lunar cycle begins, a sliver of light can be seen on the moon's western edge. Gradually, the lit part becomes larger. By the end of the first week, the moon is at its first quarter phase. In this phase, the moon's entire western half is lit. Week 2, full moon. During the second week, more and more of the near side becomes lit. When the moon's near side is completely lit, it is at the full moon phase. Then it starts waning. During the waning phases, less of the moon's near side is lit each night. As seen from Earth, the lit part is now on the moon's eastern side. Week 3, we have during the third quarter. During this week, the lit part of the moon becomes smaller until only the eastern half of the moon is lit. This is the third quarter phase. And week 4, the new moon. During this week, less and less of the new side is lit. When the moon's near side is completely dark, it is at the new moon phase. You've read that as the moon revolves around Earth, there's a part of the moon's near side that is lit changes. Let's examine what the moon looks like at different places in its orbit. So this is just another view of that simulation we saw before. So we start at the new moon. The new moon, the moon is not visible from Earth. We start then we go to the waxing crescent, where we just see that sliver. And then the first quarter, where we have half the moon lit. And then waxing gibbous, where it's like 3/4 of the moon. And the full moon. And then we start waning. So whether we're waxing or waning, if there's more than half, it's called gibbous. The third quarter, the waxing crescent, and then we're back to the new moon. The moon's motion around Earth causes the moon to rise on average about 50 minutes later each day. The figure below shows how the moon looks at midnight during the 3 phases of the lunar cycle. And we're on to the lesson review for lunar phases. So, can you identify the moon phase represented by each illustration? Do that. You can check your answers, and then let's go to the next page. We're going to use this image to answer questions 3. First question 2. A new moon occurs every 29.5 days. Why must the sun, Earth, and the moon be aligned in order for the new moon to occur? Is it because A, no sunlight is reflected off Earth at this point? Because B, sunlight directed toward Earth is blocked by the moon? C, the moon does not orbit in the same plane as Earth? Or D, the moon is not directing any light towards Earth at this point? Okay, now we're going to use this image. Okay, predict which locations which the moon is in a waxing phase. So pick the combination. Is it A, B, C, or D? And at which location is the phase seen from Earth during the second week of the lunar cycle? 1, 3, 5, or 7. So the sun is over here. Got a couple more questions. So, would the phases of the moon be affected if the moon did not make one rotation for each revolution of the Earth? Explain. And imagine the moon rotated twice in the same amount of time the moon orbits Earth once. Would you be able to see the moon's far side from Earth? Explain your reasoning. Okay, do you still agree with what you said to the science probe at the beginning of the lesson? You can go back and change your answer if you disagree. Hey, thanks for watching to the end. I hope you all have a great weekend, and I will see you on Monday.